Welcome. Today we're talking about how to find the volume of prisms. Now, since we're working with outlines of 3D figures and not actual physical fish tanks and vases and things like that, let's just imagine volume as how much water it would take to fill this object. So here's a rectangular prism, and here is the bottom of the prism. What we're going to imagine is that we're going to take that bottom and start from the bottom and fill with water. That water represents the volume of the prism. So let's look a little more specifically. What if this prism were 3 units tall? Put a little mark, a little legend on the edge there for our 3 units tall. You can imagine this as feet or centimeters or inches or whatever you want. We've got the bottom, and that bottom would just be the area of the bottom. We haven't filled anything yet. But if we fill up to the level of 1 unit, then now we have a volume. We've brought in that third dimension. We have a volume that is just 1 cubic units worth of whatever the area of the base was. So it's 1 cubic unit times whatever the base was. If we fill it up to the 2 mark, now we have 2 layers basically. These were 1 unit tall each layers. So now our volume is going to be 2 times whatever the area of the base was. And then if we fill all the way to the 3, of course now we have 3 layers. So our volume is 3 times whatever the area of the base is. Basically, to find volume of a prism, you just always find the area of the base and multiply it by the height. Here's a formula that we'll use. V equals capital B times H. So that capital B, the reason we're using a capital instead of a lowercase is because it's not just base of a triangle or other things we've used B for. This capital B is representing area of the base. So let's try this out. We're going to find the volume of the triangular prism here in this picture. Now remember, our formula for volume of prism is V equals capital B times H. Now, our capital B represents area of the base. So we have to remember in our definitions of a prism, where is the base of this prism? The temptation is to make it just whatever side looks like the bottom, which in this case would be a rectangle. But that's not what makes something a base of a prism. Specifically, the base of the prism is whatever polygon gets repeated with some rectangular sides connecting them. So our base here is actually this triangle. This is a triangular prism. So when we find the area of the base, we're going to use the area of the triangle formula. So I'm going to use that big B for area of the base equals 1/2 times little b, which is base of the triangle, times h for height. So as we fill in these values, we've got capital B equals 1/2 times 4 times 3. Simplify that down to 6. So I'm going to put 6 into our big formula up at the top for our capital B equals 6. Now our height sometimes actually looks like you're measuring something from the floor to the ceiling, but not always. With the height of a prism, you're always looking at the distance between the bases. So right here, the distance from one corner of the front triangle to the same corner of the back triangle, that's 11. So 11 is our h. Let's plug that into our formula. And now we just solve this out. 6 times 11 is 66. And we throw our units on there. We were working with centimeters, and volume is a cubic unit, so centimeters cubed. And we'll throw our final answer box around that. So overall, the challenge here in finding the volume of a prism is, number 1, to find what the base actually is, and then use the appropriate formula to find the area of that base. But once you have the area of that base, then you multiply by the height, also known as the distance between the bases. And that was the formula that we used. Thank you for joining me for how to find the volume of a prism, and I will see you next time.